Good day, stat students. So today we're going to talk about section 2.5 part 2. The other video was just getting too long, and so I just decided to stop it. I realized how long we were into it, and so I just decided to make another video with regards to z-scores. Z-scores are so important that I just needed to make sure that it gets emphasized and it didn't get lost within all the other stuff that we talked about in 2.5, because probably the most important thing that we're going to talk about in 2.5 is z-scores. Not that quartiles, percentiles, box plots, and IQR doesn't have their place. They certainly do, okay? But we're going to see z-scores quite a bit, and you would see this actually in everyday life. It's just that maybe they're not called z-scores. They're just talked about with in a different way, and I'll explain what I mean by that here in a second. Okay, z-scores. What are z-scores? Z-score is the number of standard deviations an observation is from the mean. So it's a simple concept, all right? So, for instance, let's go back to our empirical rule question. So we had the heights of all U.S. Male adults are bell-shaped, the mean of 70 inches and a standard deviation of 4. So we said mu is equal to 70, sigma is equal to 4. Okay. And remember this graph here? We put 70 right in the middle of our bell-shaped curve. Okay, and then we went out one standard deviation. Let's see, let's get my pen out. One standard deviation, two standard deviations, three standard deviations. Okay, and then the opposite way. Okay, so this is what we're going to do. I know you're probably not used to doing this, but what I'm going to do is I'm going to make another axis. I'm going to call it the z-axis. Okay, and I'm going to place it right below x. So x is in terms of height. Okay, x is in terms of height. How about the z-scores that they're in terms of something else, okay? And so what we have to do is we have to figure out for these benchmarks here, so 74, 78, 82, 66, 62, 58, and 70, what would be the z-score for each one of those, okay? Let's start with 74, all right? So how many standard deviations did we just go out from the mean, okay? So here's the mean of 70. How many standard deviations did we go to get to 74? Now we didn't go 4 standard deviations, we only went out 1 standard deviation because the standard deviation was worth 4. So how many standard deviations did we go out? We just went out 1. Okay? And what about 78? How many standard deviations there? We went out 2 standard deviations, so the z-score would be 2. And then 3 for 82. Okay? How about 66? 66, we went out 1 standard deviation, but we went left on the number line. And so what would that be? That would actually be a -1. And 62 would be a -2, and 58 would be a -3. And what would 70 get? 70 would get a 0, okay, for a z-score. So this is talked about. You'll hear this in movies and on the TV shows and stuff, and they'll say, well, something was this many standard deviations above the mean or below the mean or something, okay? And that happens all the time. I hear it all the time, okay? And so what are they really talking about? They're talking about z-scores, okay? They're simply talking about z-scores. And so let's see. Excuse me. What would give what would cause an observation to have a z-score that was negative? Well, notice that 58, 62, and 66 are all values less than what? The mean. So if an observation had a value less than the mean, it's going to get a negative z-score. And if you have an observation that is above the mean, such as 74, 78, and 82, notice they're all above 70, they're going to get a positive z-score. Okay? So you can have negative and positive z-scores. It just depends. Is it below the mean or above the mean? And if it's right at the mean, it's going to have a z-score of 0. Okay? All right. So let's go back to our problem. All right. What about the values that don't fall exactly at 1, 2, 3 standard deviations from the mean? Can we calculate the z-scores for those values? And the answer is, well, absolutely. Absolutely. No problem. Okay. And we're going to use a simple formula. Here's the formula. Now, I've modified the formula just a little bit. I put these parentheses here on purpose. Okay. Normally, you would see the numerator without those parentheses. Okay. But there should be parentheses there. Remember when you put a line straight across like that, what is that suggesting to everybody? That there's parentheses up there, okay? And so when you put this in your calculator, you're going to have to put it in there with parentheses. Okay, so even though you might see the formula without the parentheses, you got to remember, you got to throw parentheses in there. Okay, so calculate the z-score for a U.S. adult male with a height of 63 inches. Okay, now let's do this. Let's back up to here. So 63 inches is right here. Okay, so what should his z-score be between? At least we should know that, right? So 63 is right here. His z-score should be somewhere between a -1 and a -2, and it should be closer to a -2. Hopefully you would agree with that. Okay, so let's take a look. So here's the problem again. All right, so let's put it into our formula. Now I did not put the parentheses here because that's the way you're normally going to see it in a book or a formula sheet or whatever. Okay, but remember, when you put this in your calculator, we're going to need parentheses here. Okay, parentheses. So 63 minus 70 is a -7. We'll divide that by 4. Okay, and what do we get? We get a -1.75. Okay, so what does that mean? How should we interpret that z-score now? Okay, by the way, that should make sense, right? Remember, it should be closer to that -2. So if we went back to that graph, remember our value should have been very close to a -2, well, at least closer than a -1, right? So it turned out to be a -1.75. But how should we interpret that z-score? Okay, that's the important part here. Okay, so we had a z-score of a -1.75, and the interpretation would start off like this. It would say, okay, the male's height is 1.75. Now be careful. This is where you have to pay attention. Remember what the definition was. Okay, once we went ahead and changed x into a z, okay, we got it out of the units of x. it's now a z-score. Okay, and remember what the definition is here, is that it's about the number of standard deviations away. So we've taken it out of in terms of inches and put it in terms of standard deviations. So the male's height is 1.5 standard deviations. Okay, so that's what the number's telling us. And then the symbol is telling us something else. What? It's 1.75 standard deviations below. Okay, below what? The value of the mean. So there's your interpretation. Okay, so if this was a positive sign here instead of negative, we would have said the male's height is 1.75 standard deviations above the value of the mean, and this value right here would have had to been above 70. Would have been 77. Okay, so the interpretation is the most important thing. Okay, now I've done this in the past, and I've stopped doing this. Okay, that where I would say, okay, here's x, and here's, we know what the mean is, we know what the standard deviation, and let's say that the z-score for a particular person was -0.52 or something. Okay, and I would say, go solve for x. But you know what? That's algebra. Okay, that is algebra. You guys already know how to do that. Okay, and there's no reason to do it here. Okay, the most important thing to do, all right, is to do the interpretation. All right, because that's going to stay with you for the rest of the semester. And so I need you to remember this definition and remember the interpretation here. Okay. So now, there's something that I need you to understand, which is an important concept in statistics, and it gets glossed over by just about every textbook, and to be honest with you, a lot of professors. And I'm going to try to spell this out for you. Okay. In statistics, we use the standard deviation, believe it or not, as a unit of measurement. Okay, we use it as a unit of measurement. And so when we went ahead and divided through by the standard deviation, we were saying, well, how many standard deviations does it take to get from here to there? It is now a unit of measurement. And that is actually an important concept in statistics. Okay, and a lot of students gloss over it. Okay, let's not gloss over it. All right, that's why I put it in red. All right, so the standard deviation is used as a unit of measurement. All right, z-scores can be used for other things too. You can use z-scores to identify outliers. Okay, now it's different criteria than the box plot method. Okay, what it is the following: if an observation has a z-score either less than a -3 or greater than a +3, it is considered an outlier with regards to that data. Okay, will it match up to the box plot method perfectly? Nope, but they should be close to one another. Okay, and what's an outlier? What's not an outlier? All right, and so now why is that? Now recall that even for a bell-shaped curve, okay, once you get out three standard deviations out from the mean, okay, that you have 99.7% of the data there. So even for bell-shaped data, you still have some outliers potentially there on both sides. Okay, in total you would have 0.3% outliers, with regards to your data, and so this is a pretty good criteria to use also. Okay. All right, so that ends our discussion on z-scores. Thank you for your time.